Hey there game devs! This video is about how to use enums and BitFlags in Unreal game development. We'll take a look at exactly what these things are, how they operate, what they're useful for, and when to use them, or to use something else. As usual, there will be examples with both blueprints and C++ where appropriate. Let's dive right in. Enums in Unreal, and for that matter in most development languages or platforms, are a way of grouping a bunch of possible choices together under one thing. That thing is usually considered to be a type, in a similar way that a class you define as a type, and that an int and a bool are types provided by the language or platform. For example, you can define an enum called basic fruit, with entries for apple, banana, and tomato. If you then declare a variable of type basic fruit, you are saying that only one of those three things is a valid value for that variable. We might be making a game with different kinds of enemies, and create an enum declaring them like so. This would allow you to have an A-act class for your enemies, with a field of the type of enemy they were, which would then allow you to do all sorts of things, depending on what specific type of enemy they are. For example, we might call a different function when the player defeats that enemy, and drops different kinds of loot, depending on the enemy type. And we can also use this in any construction type functions, to give the enemy a different character mesh or different equipment based on the selected type, and calculate different amounts of health or set different amounts of damage that they can inflict to the player when they hit them. If we take the declaration we made in C++ and decorate it with the appropriate uProperty specifiers, like so, we now have an actor that level designers can simply drop in a level and use a drop-down list to select a specific enemy type. In this case, grunt is the default value. Obviously, for more complicated enemies with greater differences between them, we wouldn't use this approach. We would more than likely create a series of inherited classes. But for simpler scenarios like this is fine. When you create an Unreal enum in C++, which can be used by blueprints, you will, currently, declare that it is based on a uint8. Each entry you provide is assigned a numerical value, either by you directly, or automatically by your code compiler in C++, or Unreal if you make these things in the editor. By the way, an unsigned 8-bit integer or uint8 can store 256 different values, 0 to 255. So blueprint visible enums cannot have more entries than that. I would make a strong argument that if you are getting even 50 distinct enum values, you might want to think about using a database and having a table instead of that enum, or at the very least leveraging something like Unreal's data tables. It would give you more flexibility, and amending things might well be easier. There are obviously situations where this is not an option. For example, if you are developing a plugin that needs to work with a minimum of additional assets, and obviously in the case of the Unreal Engine itself, which has some pretty massive bitflag enumerations, but we'll get to those in a bit. So the fact enums are really just numbers is useful to know. For example, when we're using databases, we can store that value in a standard integer field in a table, and likewise read it back in and cast it to the enum. We can also do other things if we have knowledge of the underlying number. Consider the previous example, the game with the various kinds of enemies. If we manually number them ourselves, it might look like this. If we don't manually number them, then the compiler will do it for us, in the order that we declare them. As long as they are in the same order, then it's perfectly acceptable to do things like... You can even be sneaky and use them to store actual data, which is the unique value, as long as they are all unique integer values, in this case between 0 and 255. For example, you might say that grunt equals 10, brawler equals 20, and big cheese equals 50. You could then just use the integer value of the assigned enum as the base health value, or maybe multiply it by something else. Whatever. You get the idea. You can be creative with such things if your situation fits the data. By convention, the 0 value is generally used to define a none, nothing, or empty type value. But you're not required to do that. Not all things you might want to make enums of have a sensible none type entry, and you might decide that in all places where you use that enum, you will always declare a default value from it anyway. If you are making blueprintable enums in C++, you can decorate the individual entries with specifiers to do a few useful things. You can use the uMetaDisplayName specifier to control how the items are displayed in drop-down lists in the Unreal editor. This example allows us to have the not equal symbols familiar to C++ programmers displayed, instead of the actual text of the enum, is not equal. And if you want to provide further information to editor users, you can also apply a uMeta tooltip specifier and provide specific text to be displayed for each entry, or just for selected ones. Another useful specifier is the uMeta hidden. which allows C++ programmers to define an enum which can be used by the Unreal editor, but which will not display certain entries to the user. For example, you might have an unassigned or none value, which you decide is perfectly valid in your C++ code, but which you don't want to allow level designers to select for placed actors, so you hide it. For fairly obvious reasons, there is no option to hide entries if you define an enum in the Unreal editor. You'd be hiding it from basically everything. Yes, I'm sure there are some blueprinters who would love to have a feature that let them hide things from the C++ devs, but that wouldn't really be useful. So, in summary, an enum is basically a collection of human readable names with associated integer values. It gives us a way of writing code that talks in terms of, hopefully, understandable words, instead of just dealing with numbers, which you might easily forget the meaning of. And it also gives us the benefit of a certain amount of checking, that the values we provide are actually values that are legitimate for the variable we're assigning them to. Bitflag enumerations. Bitflags are basically an extension of enums, inasmuch as they are just enums which are declared and used in a specific way. Because we are trying to include blueprints in this conversation as much as possible, we will primarily be considering Bitflag Enums based on that uint8 size we mentioned earlier. So what are Bitflag Enums, and how do they actually work? Well, to explain that, we need to first talk about binary. So, binary. Many of you will already be happy with what that is and how it works. Some of you will be vaguely aware that it's a bunch of noughts and ones and no little more than that. And some of you will be of the opinion that you don't need to know anything about it because modern computers and software can hide it from you, so you don't need to know. Well, it's true that you can be a modern programmer without understanding binary, but you will be a better one if you do. Not only that, but certain things will start making more sense to you, and you will begin to recognize and understand certain common things which you encounter in your projects. The standard texture sizes used in 3D graphics, for example. Plus, you can get that t-shirt and wear it with absolute geek pride. So, a byte is often considered the smallest unit of computer memory. You might like to think of it in terms of physics. It's a little bit like an atom. We know that atoms are made up of smaller subatomic particles, which in this metaphor represent the binary zeros and ones, but the atom itself is kind of the smallest thing which is useful on its own. Computer memory is generally organized and addressed in bytes, or multiples of bytes. Each byte is made of 8 bits, those individual zeros or ones, and that uint8 we keep talking about is just 1 byte. I don't really want to spend too long going over how you count in binary, other than to say when we count normally, in what is called decimal, we start with the units from 1 to 10, after that we add another column. Each digit in that is 10 times more than the units column. And then in the next column, it's hundreds, which is 10 times more than the tens column, etc. Each successive column is 10 times more than the previous column. The columns in binary increase in powers of 2. What that means is the first column is a value of either 0 or 1. The next column is either a value of 0 or 2. The next column 0 or 4. Then 0 or 8, 0 or 16, 0 or 32, 0 or 64, and finally, to end the byte, 0 or 128. By specifying a value of 0 or 1 for each of those columns, we can create any value between 0 and 255. Counting from 1 to 8 in binary, shown as an entire byte with leading zeros, is as follows: 1, 2, 3, 4, 5, 6, 7, 8. For example, if we take the binary number 00101010, the value in decimal is calculated as follows: 128 times 0 plus 64 times 0 plus 32 times 1 plus 16 times 0 plus 8 times 1 plus 4 times 0 plus 2 times 1 equals 42. So yeah, how does this apply to bitflags? Well, you can think of those 8 zeros or ones almost as 8 individual booleans. If we assign a different meaning to each of those booleans, we can get something useful. So for a byte, you can have entries with the values 1, 2, 4, 8, 16, 32, 64, and 128. 1 for each bit in the byte. So yeah, it kind of seems like we went from having 256 unique enum entries suddenly down to only 8. Well, before we were just interested in one of a selection of entries, which is the current value. But now we're saying which combination of those values do we have. We are interested in the combinations, as well as the individual booleans that make them up. You can use this for things like common buffs and debuffs. You might make a tile-based game and have an enum to represent which landscape features are present on each tile: grassland, hills, rivers, roads, railway lines, etc. You need to be careful though. Firstly, if this is something you want to expose to usage in the editor, you are currently limited to uint8 based enums, which as previously stated means a maximum of 8 individual states which can be combined. If you are using these things solely in C++ code, however, you can base your enum on a uint64 and have any combination of 64 states you want. The other thing you need to consider is that those individual states are actually things that can be sensibly combined. A moment ago, I mentioned a geography-based example, which is fine in principle, but is it really okay to have values for ocean and desert, which in theory might not really be able to exist together on the same tile? I mean, you could allow it and just say you would never actually do it, but ideally we would have a series of values that make absolute sense in any combination. However, things are not always that simple, and sometimes we have to do the best we can, and we end up with perhaps 4 values that make a sensible combination together, 3 more values which make another sensible combination together, and basically 1 boolean we stuck on the end because we had a free bit left over and we wanted to use it. We could look at those things and it would be perfectly sensible to say, actually, I'll make 2 separate bit flags here and a separate boolean. Or you might say, well, this is something which is going to be replicated for network play, so I intend to keep it all together as one small compact value that will be transmitted as a single byte, probably faster than the other options. It really depends on your situation. Let's take a look at an Unreal Editor and Blueprints example. This example is going to show how we could have different currencies in our game and then convert between the values of them. First, I'll create an enum for the currencies. I'm calling it currency type. I'm going to put 4 different currencies in there. Then I create a blueprint struct that defines an exchange rate between 2 of those currencies. So it has a currency we're converting from, the currency we're converting to, and what the exchange rate is in that case. Now I'm going to make an Unreal data table to store all the exchange rates we need. I set the from currency and the to currency, and I fill in the exchange rate multiplier for each one. Because this is a data table, you could do this in a spreadsheet and import it if you wanted to. But we don't have many entries in this example, so I'm just entering it all by hand in the Unreal Editor. I leave the row name to the default values that Unreal provides for it, because I'm not really interested in them. I'll be honest with you, I don't really like the way that data tables are implemented in Unreal, at least as far as blueprints are concerned, and if I intend to do a lot of work with them, I would certainly code some blueprint functions in C++ to make the experience a little less painful. But I don't need to do that, because as you will have gathered if you've seen any of my other videos, for games that use any meaningful amount of data, I would just use databases instead. And that's exactly what I would want for something like this example. Rather than data tables, which are not really meant to be updated at runtime, databases are, and so you could fairly easily allow the player's actions to influence those exchange rates, or for a trading game, track the current price of various stocks in different locations. But this is just an example, and I digress, once again. So, next I'll make a blueprint function library and add a new function to it called convertCurrency. I'll add input parameters for the from and to currencies, and another for the amount of from currency that we want to exchange. What we want to do is find the row in the data table that has the from and to currencies we're interested in. There isn't really any simple way to do that though, as data tables work using their row name to pull individual rows out. Yeah, sure, we could kludge something together where we used a combination of the from and to enum names as the row name, but well, that's just a lot of rather pointless work for no real returns. And as we don't have many entries in there, in this case it's simpler to use a blueprint node that gets all the data table's row names and just do a for each loop over it. The result is basically for eaching over the data table rows themselves. So now that we have actual rows, we can test the from and to currency values to see if they match what we're interested in. If they do, we use the rate recorded for that row and multiply it by the amount parameter to get the result, which we return. If we don't find a row with the specified from and to currencies, we return a value of 0. But you could do whatever you like, such as returning -1 to indicate a conversion failure. And if you were going to use something like this function a lot, it might make sense to check if the from and to currencies were the same before even looking at the data table, and simply returning the same amount that was passed in if they are. Just in case your UI doesn't enforce that they are different. Belt and braces, as they say. Okay, so let's now take a look at an example of how we can use those Bitflag enumerations. We're going to make a Bitflags enum for tracking injuries to specific body locations on the player character. In this example, I start with an entry for healthy, which is set to 0, meaning no injuries. And this would most likely be the default value you would initialize variables to. When you are declaring enums and manually assigning values in C++, you're free to provide the values in a number of different ways. For Bitflag enumerations, many people have traditionally used hexadecimal notation to specify the values, and a majority of the Bitflag enumerations which Epic uses in the engine code are declared in this way. Historically, the reason is given as it's a bit clearer and less error-prone than using decimal. However, as of C++ 14, we can now write binary literals, which would arguably be cleaner than hexadecimal for declaring these enumerations, as long as we provide the leading zeros and align them all up. I don't want to get into a whole argument about which is better. For a uint 8, binary would arguably be the clearest to read in your code, but if you have bitflags based on uint 64, do you really want to type out 64 characters for each binary number? In hexadecimal, it's only 16. And of course, yet another school of thought prefers to use compile time constants, where your enum values are specified as 1 bit shifted left by the relevant number of bits, like so. The compiler will recognize these and calculate the appropriate values and plot them right in there for you. It's really up to you, but for this example, I'll specify them in binary and put the decimal value in a comment. So, back to our injury location enum. The next 6 entries indicate injuries to the player in distinct body locations, and each one is assigned one of those power of 2 values. That means in binary, each one of those values is represented by a 1 in a single binary digit or bit in the underlying byte used to store it. Following that, I've defined 4 more entries, which are simply combinations of the previous entries. This is just a way of defining particular patterns of bits that might be useful for you. Think of it as a shortcut. Instead of testing for left leg damage and right leg damage, you can just test for mobility impaired. As you can see, we can set those things by referencing the previous entries, or, as the last entry shows, by giving a specific value. So once we have a variable that's typed to our Bitflags enum, we can do various things with it. We could inflict individual wound locations on the player, additional to anything they currently have. And if they already have the specific wound we're trying to inflict, nothing would be changed. It's still injured. We can also heal specific wounded locations in a similar way, or completely heal the player. Similarly, we can test what injuries the player has and use that information in different ways. For example, we might decide that the player's movement speed is affected by certain injuries. Here, we perform the test by doing a bitwise AND of the player wounds variable with the enumeration flags we're interested in testing for. Any bit which is 1 in both the variable and the test flags will return a 1. Therefore, if the result of that is the same as the bit flags we're testing it against, then it contains those set bits. So, common operations you might want to do. Modify a variable to set the bits corresponding to a specific bit pattern. In this case, we use a bitwise OR on as many bit patterns as you like, and then assign the result to your variable. In the example above, we use C's bitwise OR assignment operator, which performs an OR on the variable and the other value, and then stores the result back in the variable. The opposite would be to modify the variable to unset the bits corresponding to a specific bit pattern. This is the inverse of the previous operation. Before, we set the bits in our variable to those in a provided bit pattern, but this time we're unsetting them. We use the bitwise AND operator with the inverted value of the bit flags you want to unset by applying a NOT operator to those first. If we want to test a value to see if a specific bit is set or a specific pattern of bits are set, we take the value and we do a bitwise AND operation with the test bits. If the result is equal to the test bits, it means those test bits are set in the variable. Sometimes you only want to know if any bits in a given pattern are used, and maybe you don't care which bits specifically. This is basically the same as the last test, and the 2 values together. But this time, we don't compare it back to the test bits. We simply test if it's greater than 0. Any value greater than 0 indicates at least one of those test bits is set. In this video, we looked at using enums in Unreal Engine. Standard enums, which group a bunch of possible choices together in one convenient entity, allow us to very easily provide drop-down list selections to our Unreal Editor users, such as level designers. We can test in code which specific choice is used, and as each entry in an enum is just a number, we can create them in an order which makes sense, and then use greater than or less than operators for certain tasks. Bitflag enums are a little bit like having a collection of booleans. It means that we can have one simple, compact way of holding information for things, which may or may not use different combinations of associated features, without needing to have individual booleans defined for each thing. Variables created from these bitflag enumerations can be set to arbitrary values and have specific bits or patterns of bits set or cleared. We can also test if a variable contains a specific bit set or specific pattern of set bits. Not only is the memory use smaller than using individual booleans, but consequently communicating state across the network could also be faster. Hopefully you can see from this basic introduction how useful enums can be, both for organizing your logic and producing cleaner code. As always, good luck with your own game dev projects, and I'll see you around in another video, or maybe in the Discord. Take care.